Namaste, Hamisha Khush Raho Betiya. My name is Manisha Singh. Today I am teaching you detection of adulterants in milk like water, urea, neutralizers, sucrose, starch, etc. In subject Advanced Milk and Milk Technology, Milk Products Technology. Lab discipline is Food and Biotechnology. Let's start with the topic. First of all, what is adulteration? Food adulteration is an act of intentionally debasing the quality of food offered for sale either by the admixture or substitution of inferior substances or by the removal of some valuable ingredients. Food adulteration takes into account not only the intentional addition or substitution or abstraction of surfaces which adversely affect nature, substances and quality of foods, but also their incidental contamination during the period of growth, harvesting, storage, processing, transport, and distribution. Adulterant means any material which is or could be employed for making the food unsafe or substandard or misbranded or containing extraneous matter. Food is adulterated if its quality is lowered or affected by the addition of substances which are injurious to health or by the removal of substances which are nutritious. It is defined as the act of intentionally debasing the quality of food offered for sale either by the admixture or substitution of inferior substances or by the removal of some valuable ingredient. Food is declared adulterated if a substance is added which depreciates or injuriously affects it. Cheaper or inferior substances are substituted wholly or in part. Any valuable or necessary constituents has been wholly or in part abstracted. It is an imitation. It is colored or otherwise treated to improve its appearance, or if it is contains any added substance injurious to health. For whatever reasons its quality is below the standard, adulterated food is dangerous because it may be toxic and can affect health, and it could deprive nutrients essential for proper growth and development. First of all, first adulterant is water. The presence of water can be detected by putting a drop of milk on a polished slanting surface. The drop of pure milk flows slowly, leaving a white trail behind it, whereas milk adulterated with water will flow immediately without leaving a mark. Next adulterant is starch. For that reagent, iodine solution is required. Dissolve 2.6 grams of iodine and 3 grams of potassium iodide in a sufficient quantity of water and make up to 200 ml volume. Procedure is take about 5 ml of milk in a test tube, bring it to boiling condition and allow the test tube to cool to the room temperature. Add 1 to 2 grams of iodine solution to a test tube. Development of blue color indicates presence of starch which disappears when sample is boiled and reappears on cooling. The limit of detection of method is 0.02%. Then detection of added urea in milk. Urea is a natural constituent of milk and it forms a major part of the non-protein nitrogen of milk. Urea concentration in milk is variable within herd. Urea content in natural milk varies from 20 mg per 100 ml to 70 mg per 100 ml. However, urea content above 70 milligrams per 100 ml in milk indicates milk containing added urea. The addition of urea to the milk can be detected by using dimethyl amino benzaldehyde. This method is based on the principle that urea forms a yellow complex with DMAB in a low acidic conditions solution at room temperature. This method is based on the principle that urea forms a yellow complex with dimethyl amino benzaldehyde in a low acidic solution at room temperature. So we need a para-dimethyl amino benzaldehyde 1.6% weight by volume, dissolve 1.6 DMAB in 100 ml ethyl alcohol and add 10 ml concentrate HCl. For procedure is mix 1 ml of milk with 1 ml of 1.6% DMAB reagent. Distinct yellow color is observed in milk containing added urea. The control shows a slight yellow color due to the presence of natural urea. The limit of detection of this method is 0.2%. Next is detection and estimation of added glucose in milk. Reagents used for this is modified Barfords reagent. Dissolve 25 grams of copper acetate in 450 ml of boiling distilled water. Add 25 ml of 8.5% acetic acid. Shake, cool to the room temperature and make up to the 500 ml. After sedimentation, filter the reagent and store in dark colored bottle. Next reagent required is phosphomolybdic acid. Take 35 grams ammonium molybdate and 5 grams sodium tungstate in a large beaker. Add 200 ml of 10% NaOH solution and 200 ml water. Boil vigorously 20 to 60 minutes so as to remove nearly whole of ammonia. Check removal of ammonia with the help of red litmus paper. Cool, dilute and with water to about 350 ml. Add 125 ml concentrated H3PO4 and dilute further to the 500 ml. Procedure is take 1 ml of milk sample in a test tube, add 1 ml of modified Barfords reagent, heat the mixture for exact 3 minutes in a boiling water bath, rapidly cool under tap water, add 1 ml of phosphomolybdic acid reagent to the turbid solution, observe the color, immediate formation of the deep blue color after adding phosphomolybdic acid reagent indicates the presence of added glucose in the milk sample. In case of pure milk, only faint bluish color can be observed due to the dilution of Barfords reagent, and the limit of detection of this method is 0.1%. Then detection of neutralizers in milk. Neutralizers are added to the milk to neutralize the developed acidity in the milk. Rosalic acid method can be used for the detection of presence of these neutralizers in the milk. The other methods available for detection of neutralizers in milk is through determination of alkalinity of ash. There are two. First of all, reagents requires are rosalic acid solution. Weigh 100 mg of rosalic acid powder and dissolve it in the 30 ml ethyl alcohol and make up to the volume with distilled water to obtain final ethyl alcohol. Take 95 ml of ethyl alcohol in 100 ml volumetric flask and make the volume up to the mark with distilled water and mix well. Procedure is to 10 ml of add equal volume of 95% alcohol in a test tube and add a few drops of 0.1% alcoholic solution, that is rosalic acid. If alkali is present, a rose red color appears, whereas pure milk shows only a brownish color. The limit of detection of method is 0.1% for sodium hydroxide and 0.1% for sodium carbonate and 0.2% for sodium bicarbonate. Test for the presence of formalin in milk. Reagent required is concentrated sulfuric acid. Take milk sample in a test tube and add 2 ml of 90% sulfuric acid containing traces of ferric chloride from the side of the test tube slowly. Formation of purple ring color ring at the junction indicates formaldehyde is present in the milk. If sucrose is present, distill the milk sample and then carry out the test on the distillate by taking 2 to 3 ml of distillate and adding 2 ml of formaldehyde free milk. The violet coloration does not appear usually when relatively large quantities of formaldehyde are present. Precautions are if sulfuric acid is added from the top and not from the side of the test tube, it may burn the milk solids and affect the end results. Hope you all are satisfied with this session. This session is powered by Digital Version 2.0 Jyoti Vidyapeeth Women's University, Jaipur. If you have any query, please mention it in a comment box. I will resolve them whenever we have a live session. Thank you so much for watching this video.